Hello, I'm Lindsay, and I'm working with Amen on our project for Engineering 460. So today we're going to be discussing mining operations, and we're going to be talking about how we're going to use the anti-sporging simulation example to kind of create a mining operations that will have kind of a similar goal. So for our particular simulation, we're going to be using 20 mining robots. And if you look at the diagram that's shown, you can see that the little red dots simulate or show the robots that are going to be used during our simulation. And obviously, since this is mining operations, the goal of these robots is going to be to mine natural resources, which we're going to talk about a little bit on the next slide. So first, we need to talk about three essential elements: the natural resources, the sensors, and the kinematics of the robots. So first, we're going to be using four different natural resources. In our case, we've decided to use diamonds, gold, coal, and copper. And as you can see shown, there's different percentages next to each of these resources. And this depends upon the amount of workforce that we're going to send it to extract each of these natural resources. So in this case, you can see that 50% are going to extract diamonds. And since we're using 20 robots, obviously this means that 10 robots are going to find diamonds once those have been discovered. And then for gold, it'll be 6 robots. And then for coal and copper, you'll see that there are going to be 2 robots each. We also have to take into account the sensors, and this is basically dealing with how the different robots send signals to other robots. So this, if you remember the ant foraging example, this is similar to the pheromones. So for instance, if a robot finds diamonds, they're going to send a signal for 9 other robots to come and help excavate the diamonds. Also, kinematics has to do with how the robots move throughout the mine. So once the simulation starts running, the robots are going to move randomly throughout the mine. And then once they find a resource, for example, if they find gold, then that specific robot is going to call 5 other robots to help mine that gold, and the other 14 robots are still going to be randomly moving and just until they find the other resources. And so there's going to be random movement going on between some of the robots until each of the 4 resources have been found.
With the mining operation as well, they will have to deal with the robot dynamics. This includes interaction with the 3D space that the robots are working in, and also the communication between the two robots. With the interaction with the 3 spaces, we're thinking the robot will have to recognize the boundaries of the entire mine they're working in, and also identifying different shortest paths that they will have to take from once they found the resources to returning home. And also they'll have to go around and avoid obstacles. So the robot will have to recognize all of those 3 things that I just talked about as they interact and go around to find those resources. Also, another thing they will have to do is to interact with one another, because we want them that once they found the resources to start talking to the others as like, I found the resources, come and help. So these robots will send signals as a way of communicating, as Lindsay was talking about. These signals will kind of act as the pheromones that the ants use to attract the others and bring them and tell them what the food was. So robot will use these signals as well to communicate to the ones that are next to them or near them, to kind of ask them or to come and help them to take the resources back home. With the workforce allocation as well too. So now that the robot has found or heard that signal that the robot sent, then they will come and they will divide resources to take from the resources found them from to returning back home. Another thing that we are thinking as we go with the mining operation is cleaning the elements. These will go from forecasting, optimization with efficient process. We'll be forecasting on how many resources are in the mine. So let's say if the diamonds are the ones that are mostly found in these mines, then we will assign most of the robots, like we said, the 50%, to go into finding those resources. But let's say there are more diamonds than gold, then we will allocate or assign these robots to go into most of these robots to go into to find diamonds than just the other ones. So this forecasting would be really with the resources that are found in this mine. For the optimization, the robots will be finding the shortest path from the resources to returning home, and also sending signals to closest robots. That means so that the ones that are next to them will come and hurry to go and help them as they bring the resources back home. And also, as I said, the workability of robots. We want to make sure that these resources that the robots carried well from the place that they were found to returning home. Well, thank you so much for joining us. This was our project.